Hello. So I thought I would shoot this video here before I disassembled this apparatus for another lecture. In response to a request from the web, somebody sent me a request to say, hey, is it possible to get rid of, for example, the delay that occurs when using the plotter? And I'm referring to, I believe, this delay here when I'm plotting the data. So to set this up, in case you haven't seen this before, I've got on this side here, I've got a Teensy on a PRT motherboard that's got a tricolor LED, and it's basically running 3-4 loops here. I have one LED going up while the other one's going down with analogWrite, so we see a brightening and dimming. This is a pretty straightforward program. 3 variables declaring the pins, set the output, and I'm going to move that out of the way. What I do want to do though is before we move on is I'm actually going to dim this out now that you've seen the two motherboards. This motherboard, by the way, is one that's going to be collecting the data that we're going to see plotted here. So let me get rid of this and dim this down quite a bit, and then we'll close this out. So that way maybe you can sort of see the colors a little better. Something like that. Okay. And I think we can, well, let's look at this. Okay. So I did a few experiments because I actually don't know the answer. In this particular case, I've got it trimmed down to the bone. I'm taking a single analog read on pin 0, so I'm only reading the change in one LED. Okay, so I'm reading the stimuli from one pin, and I'm doing a reading of it, and I'm directly outputting it, and then I'm delaying it 5 milliseconds before I plot it. I got my baud rate set really pretty high here, 115/200. You guys can see actually in Device Manager off screen here I've set the port to 115/200, and of course I have this thing set at 115/200. So everything's set up there pretty fast, so baud rate's not an issue. And you can see it's moving across pretty fluidly, a little jerkiness but not bad, and we're seeing even on this single channel single sample we're seeing some tendency here to watch the one channel rise, peak, and fall. Okay, and what I did is I wanted to play with this a little bit. You can see if I even just cut it down by 1 millisecond, I'm going to turn this one off so I don't have a crash when I try to upload. Alright, let's open up this plotter again. And you can already see it's pretty jerky. I really, at 4 milliseconds, it's already starting to, it's still working, but it's getting real choppy, and I'm losing a lot of fluidity transferring the data up to the screen. Okay, so let me switch this over to another plot. Let me just pause this and I'll be right back. So here you can see I've changed, I've got a real nice plot here, and I've pulled up a new sketch, and in this particular sketch I'm going to take and collect the data from 3 different ports, A0, A1, and A2. I'm actually going to take 100 readings. Okay, I'm going to read this. I should go up here. My smooth factor is 400. I'm sorry, not 100, 400. I'm going to take 400 readings, and I'm going to read it 400 times, and then I'm going to take that data and divide it by 400 and get sort of an average, and then I'm going to take these strings and basically concatenate them. So I have 3 different strings. Each one of these, notice it's printed, then there's a space, printed, then there's a space, and then I do a new line. Okay, so I have three numbers separated by spaces, and I'm using the serial plotter to plot it. And I get this really nice, I think very, very, very pretty graph of 100 samples averaged out. But notice there's no delay. Okay, well, I assume that's because this averaging here of 3 different ones 400 times is taking long enough that it smooths out the transmission of data, and I get a seemingly nice fluid graph. And to test that, I'm going to drop this down to, say, 300 averages. Okay, and unplug this and upload this. And let's load it up. Okay. And already you can see it's clearly not working nearly as fluidly. It's very choppy. I'm going to turn my light back on. Still working, but I'm getting really kind of yicky data. Okay. And it's certainly not flowing along at the rate that we would like to see. So even averaging it out 300 times appears to be it's going too fast, and the data is streaming faster than I can process it. But I'm going to bring that back up to 400. Let me unplug that. And now you can see the data is very fluid. And of course we get the nice graph back. Even at 350, I think this will be the last one, and I'm going to stop. So I'm going to average each acquisition 350 times. And I don't want to do them all. Obviously, I could probably sit there and figure out the optimum point within my computer and my circumstance. Oh, it's not going to work with that open. All right, so now we're doing 350. Okay, and you can see already it's going to be choppy. All right. So it appears as though, yes, you can get rid of the delay, but you still have to you have to put in something that consumes that amount of time, at least in my circumstance, transferring the data from one of these Arduino Teensies, or the Teensies that are Arduino compatible, through the serial monitor up here to the graph display. And it appears in my case to be the magic number of about 400, which seems to balance out nicely, and I get a seemingly pretty good piece of data. So I hope that answers the question, and I'll see you again soon.